Hello all, my name is Ashutosh Rastogi. I'm a teacher by profession. My mission is to impart quality education for all. For that purpose, I am creating these videos. If you appreciate my work, then please do like my video and subscribe my channel so that I could get the motivation to prepare more videos.
Anyways, in this particular lecture, we're going to discuss about T1 digital systems. These are the outlines of today's lecture. We'll start up with the introduction where we will discuss about what do we need to have a kind of standard in time division multiplexing systems. Then we'll describe about the specification of T1 digital systems. Then we'll describe about T1 frame structure. We'll discuss about digital systems and T-lines data rates. Then finally, disadvantages of our T1 systems. So in multiplexing, we have already studied that we actually have to pass information from the multiple users over the common medium so that we could effectively minimize the data transmission cost, or we could effectively utilize our available resources. Especially in the time division multiplexing, we have to make sure that the information bits that are coming from the multiple users do not overlap with each other. If this will going to happen, then obviously our complete communication system will go on through the interference, which is undesirable. So point is, how can we restrict this overlapping of bits so that we can avoid this interference? So here is the solution. The solution is T1 digital systems. So obviously if we want to avoid this sort of interference, then anyhow we all must have to follow a specific system or standard so that we can avoid the interference. So digital signal 1 is a widely used standard in telecommunications in the North America as well as Japan to transmit voice and data between two devices. So digital signal 1, which is also known as T1, is a T-carrier signaling schemes which was devised by the Bell Labs. So basically DS1 is a kind of protocol or standard which basically avoids the intermixing of signals which are coming from multiple sources. E1 is used in place of T1 outside of North America and Japan. Since T1 is the standard which has been used in North America and Japan, apart from that, the name E1 is used for this protocol. Technically, we could say that digital signal 1 is the transmission protocol which has been used over the physical T1 line. What do you mean by physical T1 line? It is a kind of physical media which is having a specific capacity. So the term DS1 and T1 are often used interchangeably. Although T1 is used for physical line and DS1 is used for protocol that has been operating over the T1 line, but we could interchangeably use each of them. So this particular figure shows the T1 digital systems. Here we will going to multiplex 24 users voice signal over the common medium. So these particular blocks are showing the 24 users voice signal, and each and every block is having a low pass filter whose responsibility is to reduce out the aliasing effect. Then all those signals will get converted to the discrete one via this particular switch. This switch is actually being taking out 8,000 samples per second for each and every individual user. Why we are using this particular term 8,000 samples per second? It is very necessary to understand it. Since we are using voice samples whose maximum frequency is 4 kHz, so the Nyquist criteria states that sampling frequency should be greater than or equal to twice of FM, that is 4 kHz into 2, that turns out to be 8,000 samples. If we are using multiplexing of voice signals, then that sampling rate should get maintained. Then after that, in order to digitize those discrete samples, we'll be using compounding and PCM, and then this digitized information will pass through these T1 lines, and then at the receiving side we're going to perform reverse operation as we have performed at the transmitting side, and at the receiving side they will get demultiplexed and individual users will get their data. So the last figure shows the basic time division multiplexing schemes, which is called the T1 digital systems. It is mainly used to convey multiple voice signals over the telephone lines. It basically accommodates 24 analog signals, which has been demarcated as S1, S2, S3 up to S24. Since each voice signal is essentially limited to a band from 300 Hz to 3100 Hz, this is the exact frequency ranges that has been generated by our vocal cord. But for all other practical purpose, we usually take the maximum frequency component produced by human vocal cord is 4 kHz, and accordingly we're going to take our calculations. So anti-aliasing filter or low pass filter with the bandwidth which is denoted by this W, that is equal to 3.1 kHz as per this maximum frequency. So the sampling rate that has to be greater than or equal to twice of FM. So we are using them 8 kHz, which is essentially greater than twice of bandwidth, that is 6.2 kHz. Means if we are going to consider Nyquist criteria, then minimum sampling rate that we demand is 6.2 kHz, but we are taking 8 kHz so that we could avoid the distortions. So each of the TDM signal is next A to D converted and companded. So as we have to use time division multiplexing in digital communication systems, then first of all they have to convert it to the digital signals with companding, which is nothing but a method to enhance the signal to noise ratio so that we could minimize the distortion. So for companding we are using ITU G.711 mu law, where the value of this constant mu is equal to 255. These are basically standards. So there basically exist two types of non-uniform quantization methods, that is A law of compounding and mu law of compounding. So depending upon in which region we are working with, we'll be using different types of standards. So regenerative repeaters is spaced at approximately 2 kilometers interval, which duplicates the signals. Regenerative repeaters, they are nothing but they will going to regenerate the bit stream that has been generated are information sources. So each frame consists of 24 into 8 plus 1, that is equal to 193 bits. So how we're going to get this particular number 193? It is very important. So please pay attention at this particular point. We'll be using the multiplexed stream associated with 24 number of users, and for coding each sampled value generated by individual user, we are using 8 number of bits. So in order to sample those 24 users data, we require 24 into 8 number of bits plus 1. So 24 into 8, that is equal to 192 plus 1. So this particular 1 bit is used for synchronization purpose. So in a particular common frame, we'll be going to have 24 users data plus 1 extra redundant bit which has been used for the synchronization purpose of various frames. So this particular figure shows T1 frame structure. So what we are doing at the input side, we'll be using 24 users information signal. Then we're going to digitize them, such as if we are using pulse code modulation systems. So in each frame, we're going to have 24 samples associated with each individual users and 1 bit for synchronization purpose. So this channel 1 is signifying the 8 bit or a single sample generated by this particular user. This particular block of 8 bits signifying the sample generated by this particular user, second user, and so on. And this pinkish color 1 bit is actually showing redundant bit which is used for synchronization purpose of frames. A single frame will going to contain 193 number of bits, but we know that in order to reconstruct our signal, we actually needed twice of FM number of samples. So in order to communicate properly, we actually required 8000 such frames. Then only we are in a state to communicate properly. So we can say that a single T1 line must have to handle all this data traffic. It means it must possess the capability to transport 8000 such frames per second. Then only we're going to converse it properly. So now this particular figure shows multiplexing of T1 lines, or we could say that T1 digital signal hierarchy. So initially what we're going to have is we're going to multiplex 24 users data, and after multiplexing whatever signal we're going to get is that will be considered as our DS1 line or digital signal 1 line. So we are calling individual users data rate as DS0 lines. So for each individual user we must have to get 8000 samples per second, and to encode a particular sample, if we are using 8 number of bits, then the total amount of data rate that we're going to have for DS0 line is 8000 into 8, that is equal to 64 kilobits per second. So for one DS0 line, the data rate we require is 64 kbps. Then one DS1 line is actually being equal to 24 DS0 lines. So what about the data rate of DS1 line? It is equal to 24 times of DS0, and for DS0 we had already evaluated the data rate as 64 kbps. So 24 into 64 kbps, that turns out to be 1.544 megabits per second. So in the next hierarchy, next higher version is DS2 lines, which is nothing but the combination of 4 DS1 lines or 4 multiplex DS1 lines. So what about the data rate of single DS line? So single DS1 line's data rate is being equivalent to 4 times of 1.44 Mbps or 4 times of DS1 data rate. That gives us 6.312 megabits per second. So next, in the next hierarchy we'll be having DS3 lines. So one DS3 lines is the multiplexed version of 7 DS2 lines. Data rate of DS3 lines, one single DS3 lines is equal to 7 times of DS2 lines, that is 7 times of 6.312 Mbps, that is equal to 44.376 Mbps. Then in the next hierarchy we'll be having DS4 lines, which is the multiplexed lines of 6 DS3. So the data rate of DS4 line is equal to 6 times of DS3 lines, that is 6 times of 44.376 Mbps, that is equal to 274.176 Mbps. So these all are the standards which are worldwide acceptable. So you just need to remember that how many multiplexed lines we'll be having in the digital signal hierarchy. So if you know the relationship about the multiplexed lines and you know the basics, then you could calculate the standard data rate of any DS1, DS2, DS3 or DS4 lines. So this particular slide shows various DS and T line rates. For DS1 service, the T1 line is having the data rate of 1.544 Mbps and we are using 24 number of voice channels. Whereas if we talk about DS2, the physical line that has been used is T2 and the maximum data rate is 6.312 Mbps, and total number of users or voice channels that we are exploiting or transmitting with the help of DS2 line is 96. Then in the similar phase, if we are using DS3 over the physical line T3, the maximum supportable data rate is 44.736 and total number of voice multiplexed users or channels is 672. And similarly for DS4, we'll be having 274.176 and number of voice channels or number of users supported by this particular line is 4032. What are the disadvantages of T1 systems? Sometimes as an input link may have no data to transmit, but as we are using frames, if we do not have any data, then also we have to pass through the redundant bits. So although we do not have any data, but then also we are using the lines, so unnecessary we are wasting the available bandwidth. So this condition will become more severe when more number of slots on the output links goes unused, which could be considered as the wastage of bandwidth. So this is the major disadvantage of our T1 system. These are the various references. Thank you very much for your patient hearing.